So our next question is solve the differential equation y prime equal to minus y divided by x, where x is different from 0. So to solve this is a simple differential equation, and to solve this we are going to use the method of separable variable. So separable variables, so that's the method we are going to use here. Now before solving, you have to keep in mind that y prime is the same as dy on dx, same thing with y double prime, which is d squared y all over dx squared. This will be very useful for second order differential equations. So we are dealing with just a simple first order differential equation. So we are going to substitute this in our above equation. We are going to have dy on dx to be minus y over x. This implies that if you cross multiply, so the idea is for us to bring similar variables together. So if we cross multiply, we're going to have x dy to be equal to negative y dx, and here we have our function in terms of x and y, here in terms of y and x. So what do we need to do? We need to bring y this way and x the other way, right? So the simple thing we can do at this moment is to divide all through by here we divide by x and here we divide by y. So what I mean by that is, if we have x dy, right, to be equals to negative y dx, here if we divide by x, we're going to also divide by x here. So we'll be left with dy to be equal to minus y over x dx. Now we have our function here and in terms of x and y, but we don't want y here, so we divide all through by y. We're going to have dy on dy divided by y to be equal to negative, this is going to cancel and we'll be left with negative dx all over x. So since we want to look for the value of since we are solving the differential equation, we have to remove the derivative sign. So to remove the derivative signs, we take the integral on both sides, and we can write this as the integral 1 on y dy to be equals to negative the integral 1 on x dx. And it's a standard formula that the integral 1 over x dx is the ln of x. And also from here you can note that the derivative with respect to x of our ln of x, right, is always 1 on x. So you have to know this. So with that in mind, our result is going to be ln of y on the numerator to be equal to minus the ln of x plus our constant k. Now ln is a natural logarithm, which is always a positive function, and in mathematics to define a positive function we use the absolute value sign. So we can rewrite this as the absolute value of x to be equal to negative ln of the absolute value of x. Okay, here is the ln of the absolute value of y equals to negative the ln of the absolute value of x plus k. And to look for our y, since we're solving for y, we have to take the inverse of the natural logarithm, which is exponent. So this is the exponent of ln of the absolute value of y equals to the exponent of negative the ln of the absolute value of x plus k. Now this is the same as the absolute value of y, because there's a property which says that e to the ln of y should be equal to y. Same thing with 10 raised to the power log of y is always y, right, because the bases are the same. So in this case we're going to have, so here we are going to apply a rule, the law of indices, which says that multiplying two index of the same power, right, if we have two index of the same power, the property is if you have if you are multiplying two index of the same base, we simply add the power. So this is the same as a x plus y. It's similar here, the only difference is that our base is exponent and our power is ln of x plus k. So what we have here would simply be, we can re-express it as this, like this. So expressing it that way, we are going to have e raised to the power negative the ln of x, absolute value of x multiplied by e raised to the power k. We notice that we notice that we have the absolute value of y to be equal to, we notice that so we notice that we can still apply our law of the law we saw above here, this law here. So this will be the same as negative ln of x multiplied by, we also notice that e raised to the power k is a constant, and this constant is simply anything, you can name it anything, multiplied by a. So the absolute value of y to be equal to minus a, the absolute value of x. So that's our solution for that question. So this is a solution.